So today I am going to continue the lab 3, another part, that is Jacobian of several variables. So I'm taking an example. If u is equal to xy by z and v is equal to yz by x, w is equal to zx by y, then prove that j is equal to 4. That is, j means here Jacobian. How to define Jacobian? J is equal to del of u v w by del of x comma y comma z. So how are you going to define this? Determinant of del u by del x, del u by del y, del u by del z. So these are in first row. Del v by del x, del v by del y, del v by del z. These are in second row. Del w by del x, del w by del y, del w by del z. These are in third row. According to the requirement, we are finding u with respect to xyz, v with respect to xyz, w with respect to xyz. First, we find the first row values, del u by del x differentiation 1. So 1 into y divided by z. So on simplification, we get y by z. Differentiate u with respect to y differentiation is 1. So x into 1 by z. So that is equal to x by z. Differentiate u with respect to z. Keep it xy as it is. Xy into 1 by z differentiation is minus 1 over z square. So on simplification, minus xy by z square. So differentiate v with respect to x. Keep it yz as it is. 1 by x differentiation is minus 1 over x square. So on simplification, we get minus yz by x square. So differentiate v with respect to y differentiation 1. So 1 into z divided by x. So we get z by x. Differentiate v with respect to z differentiation 1, y into 1 divided by x. So y by x. So differentiate w with respect to x differentiation is 1, z into 1 by y, z by y. Differentiate w with respect to y, zx is constant, keep it as it is. 1 by y differentiation is minus 1 over y square. On simplification, minus zx by y square. Differentiate w with respect to z differentiation is 1 into x divided by y. So on simplification is we get x by y. So put all the values in the determinant. So make it denominator z square, x square, y square in the first, second, third row respectively. That is, want to make this z as z square, because here z square is there in the last term of the first row. So make it uniformly. So in order to get the common factor. So in the similar manner, in the second row, to multiply by x and divide by x for these two terms. And in the third row, multiply by y and divide by y in the third row for these two terms. So in order to get uniformly, okay. So after getting this, take 1 by z square as common factor in the first row, 1 by x square in the second row, 1 by y square in the third row. So we just left with the yz, xz minus xy, minus yz, xz, xy, yz minus xz, xy. Take out the common factor yz, xz, xy in the first, second, and third column. Okay. So after taking this, now y into y square, this y square cancel, z into z square, this z square cancel, x into x square, x square. So it is cancelled. Now we just left with determinant 1 1 minus 1 minus 1 1 1 1 minus 1 1. Expand the determinant. So plus minus plus determinant. So 1 into, leave this column and row. 1 into 1, 1, minus into minus plus. So plus 1. So middle term is minus always. So minus 1 into, leave this column and row. Minus 1 into 1, 1, minus 1 into 1, 1, minus 1 into. So leave this column and row. Minus 1 into minus 1, 1, minus 1 into 1, 1, 1 minus 1, 0, 1 into 1 plus 1, 2, minus into minus plus 1 into 1 plus 1, 2, 2, and this is 2, 2 plus 2, we get 4. So just we look at this in the program line. Jacobian. For Jacobian also, we required a SIMP module. From SIMP module, we are importing star as to write problem in program line, and we required symbols x, y, z, and that is stored in x, y, z variable. In third, fourth, fifth line, so just by using the star, write the problem in program line. U is equal to x star y by z, or x star y by z stored in u, y star z by x stored in v, z star x by y stored in w. After writing the problem in program line, find all the first order partial derivatives. Differentiate u with respect to x, diff u comma x stored in dux. Differentiate u with respect to y, diff u comma y that is stored in dy. Differentiate u with respect to z, so diff u comma z that is stored in duz. We can just show this print dux. Okay, so same thing. So y by z, x by z, xy by z square, like that. So similarly, differentiate v with respect to x. So if v with respect to x, that is shown dvx. If v with respect to y, that is stored in dvy. If v with respect to z, so that is stored in dvz. So I can show this also. I just ran this z by x, y by x. Okay, so minus yz by x square. So here also I'm doing same w w w. Just I want to run this. So y by x, z by y, minus x by z by y square. So differentiate w with respect to x, that is stored in dwx. Differentiate w with respect to y, that is stored in dwy. Differentiate w with respect to z, that is stored in dwz. So we get the values of this. Okay, then we have to construct the Jacobian matrix. So how do you write the Jacobian matrix? J is equal to matrix of, so starting with a curvy bracket, then you use box bracket. So in that box bracket, first bracket dux comma duy comma duz. This is represent first row, comma. So another box bracket dvx comma dvy comma dvz. So this represents the second row, comma, and lastly another box bracket dwx dwy dwz that represent third row. So then print the Jacobian matrix is. So why you are putting slash n means, or forward slash why we are putting forward slash here. So here in order to show the characters separately, don't mix up. So the characters must be should be spaced, some spaces. So that's why we are putting slash. Then at last display j. So here we are displaying j. Okay. So find the determinant of the Jacobian matrix. Determinant we have to show. Okay. So determinant of j dot do it. So forcefully we are ordering that. So do the determinant that is stored in Jac. Then at last print double slash n j is equal to Jac. So that is why you are putting double slash means. So the space of this matrix and j should be have some space. So if you take this remove this and run, so it's having less space. In order to show more space, so we are putting slash. That is the thing. Here also we can done the same one, slash n. Let us try here also. If it remove this, just run this. Only we get this. This one is. So the similar manner we can make it space from the characters. Okay, so this is about the Jacobian of the matrix. Okay. Thank you.